All right, guys, so this is Anova. This is going to be an extremely low budget academic presentation. So the first thing that we want to look at is what kinds of problems are we going to attack with Anova? So the kinds of problems we attack with Anova are problems like this. So we have a researcher and they believe that the average earnings of actors, athletes, and musicians are the same. So the earnings in millions for several randomly selected people from each category are shown over here. Oh my gosh, they make more money than I will make in my entire life. Thinking about this, right? Everything's in millions. So our friend here is making $75 million. Yeah, that's a lot of money. So the claim is that all three of these groups, on average, make the same amount of money. That's what we're looking at. So we're going to assume that the underlying population is normal. The samples are independent of each other, which means that when I selected my group of actors, that didn't in some way impact selecting the group of athletes. So that's actually kind of a tall order. Think about some actors / athletes like Michael Jordan, Space Jams. Which one is he? Anyways, leave that aside. And the other assumption is that the population variances are all the same. So at a significance level of 10%, can you reject the claim that all of the mean earnings are the same for the three categories? So we're going to investigate whether the averages are equal using this thing called Anova. So what is Anova? What does this thing stand for? Well, just you wait, because we're going to find out. Okay, so one-way analysis of variance is a hypothesis testing technique that's used to compare the means of three or more populations. Analysis of variance is abbreviated Anova, analysis of variance. So to begin, we're only really going to talk about one-way analysis. You first need to state the null and the alternative hypothesis. So for a one-way ANOVA test, the null and alternative hypotheses always look like this. So null hypothesis is that the means are all the same. And then the alternative hypothesis is that one of the means is different. So if you reject the null hypothesis, you can conclude that there's one mean that's different. But unless you perform more tests, you can't actually say which one is different. So you can't say like, oh, the actors are different. You can only say, well, one of these three is not like the others, right? Okay, so before you perform a one-way ANOVA test, you have to check that these conditions are satisfied. So the first one, you've got to have a normal distribution for the underlying population. Second one, the samples have to be independent. Okay, so remember Michael Jordan, Space Jams, right? He might cause a problem with ours, but we're assuming that maybe he's out of the pool because he retired. Yes, he retired. Okay, and then we've got that each population has to have the same variance. So let's look back at our example. So we have a couple things that we need to look at. So first of all, we need our calculator steps. I'm going to put my calculator steps right over here. Second of all, I need my handy dandy problem steps right over here. Okay, and I've got my calculator and I've got my cheat sheet that has the answers on it. Hold on. I'm gonna cover this up. Okay, well, bam, and we're back in action. So we're back to this problem about our actors, our athletes, and our musicians. And the first thing I need to do is state my null and alternative hypothesis. So the null hypothesis was that statement of equality, the statement that all of the means were the same. So my null hypothesis is that the mean for the actors is equal to the mean of the athletes, and that's equal to the mean of the musicians. The alternative hypothesis is that at least one of the means is different. Okay, you aren't going to be able to tell which mean is different. You're only going to be able to tell that one of them is out of line. All right, step 2. state the value for this level of significance, your alpha value. So if I look in the problem, it says right here that alpha is at 0.1. So a 10% significance level, step 2, alpha is 0.1. Step 3, use the calculator to obtain your p-value. Calculator directions. So the first thing we need to do is we need to put our data into the lists. So to do that, we go to Stat and then 1 to edit. So I've actually put my 3 lists in, but you might want to pause the video if you're following along and put your 3 lists in so that you can do the same steps on your calculator. But because watching me input like a million numbers is not very fun, we're gonna leave it the way it is. Okay, so step 2, press Stat. Bam. Step 3, arrow over to Tests. Doop, doop. And then I need Anova. So Anova is like all the way at the bottom, but pro tip, arrow up, and you're there. Enter. Okay, so on the next screen, you want to put in the lists that you're analyzing. So I put into L1, I've got my actor data, L2 is athlete, L3 is musician. Keep track of where your lists are, because if yours, like maybe your L4 is like, you know, random data like phone numbers. I don't know what you store in your calculator. Then if you select L4, it's going to be included in your Anova test and you don't want it. So now I've got to do second 1 for L1, comma, second 2 for L2, comma, second 3 for L3, and close my parentheses. So now your screen should read this. Holy hot dog, it sure does. Press enter. And we get all this stuff. Oh my gosh. Look, so many things. Okay, so what do I actually care about? The only thing I really care about right now is this p-value. P is my p-value for the problem. It's what I'm going to be comparing alpha to. So I now have p. So over here, if we're following along, p equals 0.06859. I've rounded it. And I can move on. So if p is less than alpha, I reject the null hypothesis. If it's greater than alpha, I fail to reject the null hypothesis. So p is 0.06, a is 0.1, p is less than a, reject the null hypothesis. So the last thing I need to do is I need to interpret the result. So there's a couple of things that I want to include whenever I'm interpreting my results. So one of them is the significance level. Okay, I need to make sure that I include the significance level. I did note whether I've rejected or failed to reject the null hypothesis using the phrase there is enough evidence to support or there is not enough evidence to support. So that needs to be in there. And then the context of the problem needs to be in there. What is the claim that you're actually refuting or accepting? So my interpretation reads, there is enough evidence because I've rejected the null hypothesis. I began my sentence with there is enough evidence at the 10% significance level, that's me including my alpha value, to reject the claim that the mean earnings are the same. All right, guys, so that was our beautiful Anova presentation. It's an extremely low budget academic presentation. I hope you all have a wonderful break, and I will see you around campus. Bye.